Welcome to this tutorial about functions, relations, and the difference between them. Let's begin with the definition of a relation. A relation is a set of ordered pairs. For the most part in our course, we'll be using ordered pairs of numbers, but note that this definition holds true for any abstract set of ordered pairs. You could have a relation that mixed letters with colors. For example. We'll be representing our relations with numbered ordered pairs in one of four ways. We can graph them, create a t-chart, create a mapping, or a list of ordered pairs. Here we see a relation with four ordered pairs. It's represented as a t-chart. Let's take a look at this same relation represented as a list. Because a relation is a set of ordered pairs, we're going to use these curly set brackets. The ordered pairs can be put in any order. 3, 4. This line here would be 6, 5. And then we have 2, 5. And we can close off with another curly set bracket. So these two ways of representing the relation are identical, just in different forms. With a mapping, we create one region that contains all the x values, usually put them in order, 1, 2, 3, 6, but you're not required to, and another region that contains all of the y values. Don't list any repeats. So you can see that 5 is repeated here. Just list 2, 4, and write the number 5 just once. Then draw arrows that map the x values to their corresponding y values. So the ordered pair 1, 2 would be represented over here as an arrow from 1 to 2. Then we'd have an arrow from 3 to 4, an arrow from 6 to 5, and also an arrow representing the ordered pair 2, 5 that goes from 2 to 5, like that. So you can see that we have 4 ordered pairs, and we have 4 arrows representing those 4 ordered pairs. If you're familiar with the terms domain and range, then this circle here represents the domain, which is the set of all x values, and this circle here represents the range, which is the set of all y values, and we'll be talking about those a little bit later in the tutorial. To graph these ordered pairs, we would simply graph the 4 ordered pairs. So 1, 2, 3, 4, 6, 5, and 2, 5. If you're given a graph, you should be able to generate any of the other 4. These are the 4 ways you can represent a relation. A function is a special kind of relation in which each domain element, or x value, maps to exactly one range element, or y value. Another way of saying this is that each x value can only be paired with one y value, or each x value can only appear once. If you have a graph of a relation, you can use the vertical line test to see if it's a function. Draw as many vertical lines as you want. If you only hit the graph once with each vertical line, then you know it's a function. If you can hit the graph twice or more, then you know that it's not a function. Let's take a look. Is this a function? First, let's graph the ordered pairs. Actually, before that, let's put a scale in our axis. So 10 and 10. 3, 4, 4, 3, 5, 2, 1, 2, and 0, 7. We've graphed this relation. Now draw as many vertical lines as you want and try to hit the graph twice. As you can see, it's impossible to hit the graph twice. We would say that this passes the vertical line test, and therefore it is a function. Let's take a quick look at the x values. 3, 4, 5, 1, 0. We can see in this situation, just by looking at the list, there are no repeated x values. That's another way of determining that it's a function. No repeats in the x values. The vertical line test is a visual way of testing to see if there are any repeated x values. Is this a function? You're encouraged to pause the video and try this one yourself, and then hit play to see my answer. Okay, I will graph the ordered pairs 3, 3, 3, -3, 2, 5, 0, 2, and -2, 7. Because we can draw a vertical line at x equal to 3 that hits the graph twice, this fails the vertical line test, and it is not a function. Notice that you could determine this by looking for repeated x values. Because you have a repeated x value, again, you know that this will not be a function. We will close by looking at domain and range of a function. The domain of a function, or relation, by the way, this also applies to relations. The domain of a function or relation is the set of all first items in the ordered pairs, and typically, when we're working with numbers, those are the x values. The range is the set of all y values. Let's take a look at an example to close this tutorial. Here we have the domain would be the set of all x values. I'll write D for domain. We'll use the curly set brackets. We have 3, 4, 5, 1, 0. Typically we write these in numerical order, but it's not required. 0, 1, 3, 4, 5. That's your domain. The range would be the set of all y values. 4, 3, 2, 2, and 7. When you have a repeated value, do not list it twice. 2, 3, 4, 7. And there's your range. I hope this tutorial has been helpful to you. Have a great day.